Assalamualaikum and hello. Welcome to HERR Group. HERR stands for Healthcare Engineering and Rehab Research. We are under Kulliyyah of Engineering in the National Islamic University, Malaysia. So, HERR aims to solve problems related to healthcare and rehab through technological advancement. Our research in line with the third Sustainable Development Goals, which is good health and well-being, and also we are working forward for SDG 10, which is reduce inequalities. The vision of HERR Group is to become a leading research center in the field of healthcare engineering and rehab, and our mission is to produce and offer excellent research and innovations that continuously improves the mobility and function for community through engineering. So these are the research area. The first one is rehab robotics, and the second one is the assistive technology, and the third one is biosignal processing. The final one is biomedical instrumentation and sensor. So these are the team members of HERR. We have 10 members as of now, led by Dr. Siti Fauzia Tauha, and the members are Dr. Nick Nur Wahidah, Dr. Nur Liana, Dr. Nur Hidayati Diana, Dr. Syamsul Bahrin, Dr. Hasmawati Antung, Dr. Farahia Jasni, Dr. Muhammad Afif Usman, Dr. Sinira, and also Dr. Anish Azwani. And we also have a few associate members, which is Associate Professor Sharul Naim, Dr. Hazrin Hani, Dr. Aliza Aini, Dr. Azmi Nabila, Associate Prof. Dr. Salmia, Prof. Dr. Amir Akramin, and also Dr. Hazrin.
Assalamualaikum warahmatullahi wabarakatuh. I'm Dr. Sinira, and I would like to introduce some of the works that my team and I had done. Okay, the first one is on upper limb rehabilitation robot with assist as needed control strategy. In this robot, the torque is provided based on the patient's ability level, where we measure the patient's quality of movement and also completion time. And then the function of this robot is to encourage the patient's own participation in the therapy. Okay, and then we also had done studies on hand rehabilitation machine. The machine is made for stroke patient whose hand are in grasp condition normally. So usually the therapist has to open the patient's hand manually during the exercise. So with the help of this machine, this exercise can be done automatically. And then we modified the arrest mechanism that is usually found in the camera shutter to provide this opening and also closing movement. And then we also have studied on emotion-driven upper limb rehabilitation robot, where we place stretchable sensors on the user's face, and then using machine learning, the human emotion will be detected, and then based on this emotion, the speed of the upper limb movement will be regulated. So in this machine, we designed this machine so that it can provide comfort during the therapy or exercise. Okay, if a person shows a happy face, which means that he is comfortable in using the machine will move fast. And then if he shows disgust, which means that he is uncomfortable, the machine will move slowly. And then if he shows a sad face, which also means that he is uncomfortable, the machine will stop automatically. And then we also analyze human hand during eating, where we study the elbow and also wrist movement while eating solid food such as rice, and then while eating liquid such as soup, and also mixed food such as liquid such as cereal and also milk. And then we also study while the person is eating with fork and also spoon. Okay, and then we also have prosthetic and artificial hands. Okay, for this hand, it is actuated by pneumatics. It can grasp objects with various size, shapes, and also weights. And then we also have spring hands, where the fingers is made of springs. And then where we also have a shoe tying robot, where we have a pair of hands, and then we program the sequence of movement of the hand so that it can tie shoelace. And then we also have EMG driven hand, where the fingers movement is driven by the EMG signal. And then we also have study on cooperative robot, where we have a pair of hands like this, handling deformable objects such as tomato, so that it will not damage the tomato while moving it.
Assalamualaikum warahmatullahi wabarakatuh. Do you know that there exist materials that are called smart or intelligent materials? In what sense are they smart? Smart materials are materials that react to external stimuli such as stress, moisture, electric and magnetic fields, light, temperature, and etc. These stimuli will alter the properties of smart materials, which makes them beneficial in a lot of areas including aerospace, medical, textile, construction, automotive, and many more. Some of the examples that are going to be highlighted in this section includes piezoelectric, which induce voltage due to stress, shape memory alloy or SMA changes its shape due to temperature changes, and magnetorheological fluid or elastomer that reacts to magnetic field. In the area of biomedical applications, smart materials can do wonders. Prosthetic limb equipped with magnetorheological fluid damper can help improve amputees' walking gait. The damper, filled with magnetorheological fluid, changes its rheological properties under the presence of magnetic field. Thus, the damper can be semi-actively controlled to match the desired damping characteristics throughout the walking gait. Shape memory alloys, as the name implies, can remember two distinct shapes, at a high temperature shape and at a low temperature shape. For example, the figure here shows a coronary stent that is used to treat narrow or weak arteries. This stent is placed in an artery to restore blood flow through narrow or blocked arteries. Inside the arteries, the stent will expand at the body temperature. The stent will then resist forces on it with an opposing radial force. Piezoelectric has been widely used in energy harvesting devices. In order to have implantable sensors within the body, they need to have convenient source of energy. If the sensor is battery powered, future surgery will be required to extract and replace the battery. This is a current problem with pacemakers and limits the number of sensors placed after surgery. Thus, to overcome this issue, energy harvesting through the body's movement via piezoelectricity is one way to avoid the need for battery replacement.
Hello and Assalamualaikum everyone. I'm Ami Ghazali from Department of Mechatronics Engineering, IIUM. So my research interest is about designing social cues for effective social robots. So before I elaborate my research interest, let's see this video first.
Hello everybody. Thank you for attending Imi's defense. You guys look awesome and marvelous. Today, Imi and I are very excited to share with you the findings of her PhD works on designing my social cues as a persuasive robot. I pass the floor to you, Imi. You are the best. So, do a great presentation. It is a must.
Okay, so basically what you saw just now is a recording intentionally from my PhD defense. By the way, what you saw just now is a clear example of a virtual robot that trying to motivate me to do a good presentation for my PhD using several social cues, such as you can see that the robot blinks its eyes. It has a similar gender with me, which is a female, and also use social praise in which the robot praise me at the proper or a very good timing. So as we alert that robots are excellent in repetitive work with the absence of psychological needs, since we will share the world with robots. So I'm interested to design robots that looks and behave like humans to activate social phenomena in human-robot interaction application. So basically my target is to design a persuasive robot that try to influence people in making decisions. So in general, I'm interested to know how should we design the social cues for social robots or persuasive robots so that the persuasive attempt will be effective and positively perceived by humans. What does it mean by social cues is how the robot should talk and behave so that people will willingly follow the advice given by the robot, have higher trust towards the robot, and also like the robot. For now, my research focus more on designing social cues for social robot to be applied to autistic children, to people with mental health issues, and also in general persuasion activities such as motivating people to do recycle. So that's all for me. Thank you.
Autism is a spectrum disorder that affects child differently and to a varying degree. So since it is a spectrum, it means that no child with autism is the same. In one-to-one therapy for kids with autism, for example, the kind of therapy delivered depends on what it is that the child needs at that time, meaning that not each child will receive the same treatment, or what they need might be different even though they have autism. So what the robot will do is not to actually replace the therapist. What we are working on the robot is to actually act more of a helper for the therapist during therapy, so that the therapist can focus more on the needs of the child itself. A lot of autistic children actually are keen with technologies, which is why we are working with the robotic system. What we are currently working on is that we will integrate thermal cameras with the robot so that the robot will be more autonomous, in which it will react according to the child's emotional state at the time, and then so that the therapy can have more time focusing at the child instead of just focusing on the tablet.
What sound did you hear? Showing the tablet. Amazing! It's a cat.